Alrighty. So coming up next for us, great speaker in-house, Steve Syfuhs, who will be presenting on deprecating NTLM and other, deprecating NTLM is easy, and other lies that we tell ourselves. So I hope you all enjoy.
Thank you very much.
No problem.
All right, how's everyone doing? I didn't even do anything and you're clapping. Okay. As he said, I'm killing NTLM, or at least I'm... Thank you. Like I said, I'm done. You might be shocked to find out that NTLM is everywhere. It's kind of a pain in the ass to kill. Dustin showed. It's incredibly dangerous.
It's like PFAS or something.
Yes. The good news, at least, is that he was talking about NTLM v1. I'm talking about NTLM v2. So when I say deprecating NTLM, I actually mean the whole suite of things. We're not just killing NTLM v1. Incidentally, we actually killed NTLM v1 already when we introduced Credential Guard in Windows 10. The problem with that is you have to turn Credential Guard on. Oh well. So let's do some level setting. So, everyone kind of has heard of NTLM. At the very least, you saw a presentation earlier showed how incredibly easy it is to break. But let's do some level setting. Let's talk about how it works, what it is, why it's important, why it's so terrible. And at its base core, it is an authentication protocol. I, as a user, want to go talk to a file server, a mail server, whatever. And that thing that I'm talking to wants to know who I am. And the value of that is, from an NTLM perspective, we're doing it in such a way that we are doing it indirectly. So I am saying, hi, I'm Steve. And what ends up happening is I'm not telling you my password. That is a critical piece of information because if I tell you my password, now you know my password. That's not great. So NTLM works separately from other protocols because it doesn't send you your password. It does a challenge response thing. And it gets used in Windows. Historically, it was one of the first authentication protocols. But these days, it gets used as a fallback mechanism when I want other protocols to work, like Kerberos or OAuth, or things like that. And usually what happens is NTLM comes into play when we are trying to negotiate another protocol that is better of some sort. And there are cases where we cannot negotiate a better protocol. There are 3 of them primarily. There are workgroup accounts, local user accounts. So if you're on a non-domain joined machine, or you are on a consumer account, or it's 1997, something like that, you end up using NTLM. There's nothing else you can use. It must be NTLM. When you're using a consumer account, when you're doing MSA, Microsoft account, like when you're MSA joining your machine. Fun fact, how many people have tried the MSA passwordless thing where you don't log in with a password anymore? A few people. How many of you tried to RDP from or to that machine to another passwordless box? Yeah, a couple people. Doesn't work. You want to know why it doesn't work? NTLM. Thank you, NTLM. There's a whole history about why that doesn't work, but it's because NTLM is stupid. And of course, there are scenarios when you have a misconfigured domain where we've tried to do something better, like Kerberos, can't, because name resolution failures or line of sight or things like that. And as a result, we can't negotiate something better, so we switch to NTLM. And so the way that NTLM works is, like I said, it's a challenge response protocol. What a challenge response protocol is, I've talked to a server. The server says, who the hell are you? And it says, well, The server is saying, I need you to prove you are who you say you are. And more importantly, I need to know at this exact moment that you are actually holding on to a credential of the person you say you are. There's a lifetime guarantee of that. And so what a server does is it challenges. It says, I need you to do something with this message. And the client says, OK, I have this message. I have a username. I have a password. And I'm going to, in this case, in the NTLM case, I'm going to do an HMAC, which is a hashed message authentication code. Doesn't matter what that means. It's a cryptographic operation that basically says I have a key, which is the password, and I'm operating over some value, which is the challenge in the username. And the server says, OK, cool, whatever. Cool, you're logged in. You now have your access to your file share, your accounting software, your whatever. So why is that bad? A couple of reasons. First of all, crypto sucks. We're talking old crypto, super old crypto. Dustin was talking about DES. We're not doing DES here. This is NTLM v2. DES, broken. Horribly, horribly broken. Gone in hours. HMAC, MD5, and MD4, a little less broken. Still broken, a little less broken. The actual problem is that MD4 and HMAC MD5 are incredibly fast operations. So much so that if I execute this hundreds of millions, billions, trillions of times a second, I can guess what values I want them to be. That's what the cracking operations are. And depending on your scale, this can be really easy or really hard. And I have this number, 1.22 THS. That's terahashes a second. So that's 1.22 trillion hashes a second. And if I have an 8-character password, which for a very long time was what we recommended, collectively as an industry, 8 characters was pretty good. 3 minutes, that's nothing. It takes no time at all to crack that. And as a result, if I am doing that with a message that is this HMAC MD5 over a challenge going across the wire, if I've intercepted that and I have 3 minutes to attack it, you're done. Your domain admin is hosed. But what is 1.22? What is that? Well, let's look at it at a scale that we understand. How many play video games? Yep, a lot of people. How many of you have 3080s or some equivalent? Few people. It's a pretty high-end graphic card, or at least it was at the time that I actually created this slide, which is a couple years ago. 1. And then you also have someone who is a lot nastier. These are, gangs. These are organized crime. These are nation states. People who have a ton of money that really don't like you. And then you have 1.22 terahashes. It's like 30 3080s. I have a 4080 in my desktop. I know, I'm special. 15 of them. It's 4080 will crack approximately 2.5 times faster than a 3080. So that's 15 of them. I looked online right before this presentation of 4080 anywhere from $1,000 to $2,000, depending on what you get. So that's $15,000. It's a lot of money, but it's also not a lot of money. And if I'm taking $15,000 to crack 3 minutes to crack an 8-character password, I've sold itself. That's nothing. So the cryptographic pain of NTLM is very obvious. So it's not great. Another issue with NTLM is that we don't have server auth. And server auth is actually really important, so much so that we have an entire protocol dedicated to it, TLS, right? The point of TLS is that I'm connecting to my bank, and I want to make sure that I'm connecting to my bank and not some random phishing site or some whatever, or worse, a site that is intercepting my bank's website. That's the point of server auth. The thing that I'm connecting to is the thing I want to connect to. NTLM doesn't have that. It just doesn't care. It will take the challenge, it'll run an HMAC over the challenge, and it'll fire it off. There's nothing about it that says that this is the server that I'm actually talking to. There's nothing to bind the request that I'm making to the server that is supposed to accept the request. That is, as a result, how we end up with attacks like relaying, proxying, things like that. Very, very nasty. Over the years, we've bolted on other stuff. You may have heard of things like extended protection or channel binding or token binding or things like that. And they kind of solve these problems, but not really. And you have to bolt it on, meaning that it's not part of the NTLM protocol. So if you're just implementing NTLM, by default, you don't have server auth. Not great. And lastly, passwords. Who loves passwords? No one. Well, one person raised their hands. Passwords are terrible, right? Humans, by and large, we suck at generating passwords. We suck at remembering passwords. And I'm being very negative by saying suck, but it's true. We're actually very bad at it. We have this ability to generate patterns in our head, and we have this ability to recognize patterns in our head. And the problem is, patterns are not random. By definition, they are not random. And in order for a password to be good, it needs to be random. Therefore, we don't generate good passwords. So that's a problem if we have a protocol that only understands passwords. It's not great. Oh yeah. Sometimes coding is hard. We sometimes make mistakes. My team owns NTLM. We own authentication in Windows. We are the ones that have to fix these things. We are the ones that stay up late. We're the ones that bang our heads against desks. We're the ones that have to look at this and say, oh, for God's sake, right? So we want to kill it. Why don't we? It's just code. Rip it out of the program, or rip it out of Windows. That was not what I was expecting people to laugh at. We could, right? Just delete the folder. That's the literal code. Like, that's the folder in the code in Windows. Believe it or not, Windows, it's just code. There's nothing special about it. It's a humongous repo of code. But there is one folder. It's MSV SSPI. That is the NTLM code in Windows. We could delete it. It'll break the world. Probably actually will break the Windows compile. I don't want to risk my life or my job on that. So what do we do? Well, what can we do? Well, we have to figure out a way to kill it. So let's talk a bit about who's doing the killing. My team's AP, authentication platform. We're Windows. Like I said, we own all of this crap. We are the ones that you blame when your password cannot work and you cannot log in. We're the ones that broke Kerberos RC4 last year. You're welcome, by the way. I meant that actually sarcastically. It wasn't supposed to be a club. We didn't actually mean to break you. We were trying very hard not to break you, and we did it anyway. And we have a whole suite of teams, like our servicing team. Believe it or not, my team, we own all of the code in in the authentication code in Windows. But the code that you use on a daily basis is owned actually by the servicing team. So like, I am 6 months ahead of what everyone is in this room is using. And the servicing team is actually the ones who get blamed when things break because they're the ones that broke it because we told them to. Then we have our SMB team. SMB is a huge attack vector for NTLM because it's super easy to use. It's super easy to coerce it into giving you an NTLM challenge response. And then there's the MSRC team who's just pleading with us, please kill this goddamn thing. Sorry, I'm trying not to swear and I'm doing a bad job. And then there's the supporting people, the support people who are fielding questions and hate mail from you who are telling us, please kill NTLM. And of course, Azure, who actually has to deploy all of this stuff into a multi-million machine distributed system that at any given point in time might be affected from a security thing. So not great. And they're all asking us, it's a team effort. We have to figure out how do we kill this thing. And in order to kill it, we have to look at it from a perspective of, okay, well, why can't we kill it? And so as a result, we have to look at, well, why do people use it? What is good about it? Well, in order to kill it, we have a bar graph. We want to go from 0, which is where we're at, to where we want to be, which is completely removed from the product. I'm going to be honest with you, it's never leaving the product. It might be off by default, but at some point in time, someone will have to turn it on, and it'll be there, but it'll be off by default. So we want to get from 0 to 100. Well, one of the interesting things about NTLM is this concept of line of sight. When I want to authenticate to a service, sometimes I can just go talk to that service. I go talk to the file share. I go talk to my email service. And that thing goes and talks to whoever it needs to talk to, in this case, Active Directory. Well, in more modern protocols, Kerberos, OAuth, web-based protocols, WS-Fed, SAML, things like that, there's a third party. In this case, we have a third party. It's the thing proving you are who you say you are, Active Directory, Entra. But in order to do that, we actually have to go talk to them first. That's kind of annoying. Why don't I just go talk to, I don't give a crap about authenticating to this other thing. I want to go talk to my file share. That's really the important thing. Authentication is secondary. No one in this room actually cares about authentication. The thing that we care about is the thing on the file server, right? It's the Excel spreadsheet. It's the website that contains our accounting information, right? It's that stuff. Security is secondary. The business is what's important. That's the thing we care about. It just happens that in order to be able to access the thing we care about, we have to authenticate. And so if we make it more difficult by requiring us to go to this other thing, it's kind of a pain. NTLM solves that. It just doesn't care. It just goes directly to the thing, and that thing forwards it on. That makes up, give or take, 5% of all NTLM authentication. And I say 5%, and I'm kind of making that up. I'm being a bit hand-wavy. It is based on real numbers. It's based on telemetry, so it's anonymized. It's aggregated. It changes on a fairly regular basis. I checked it yesterday, and the frickin' thing went down to 4%. So I didn't update my slide deck. 5%, give or take. Next, unknown server. Remember, I talked about this. It doesn't care who you're talking to. So if I have to go all the way over here to a domain controller when I'm doing Kerberos or OAuth or something like that, and I say, I need to go talk to this file share. And that thing's going to say, what file share? I don't know who that is. NTLM doesn't have that problem. You can just fire a request. It's username and password, and that fires it off to the domain controller. The domain controller says, oh, well, I know this user. I don't know what server you're talking to, but I know the user. So it's good. That's a double-edged sword. In aggregate, that's about 14%. That's an aggregate number of different things. That is IP address based. One of the fun things is IPs are hard. They change because of DHCP, things like that, leases, whatever. We don't necessarily know who an IP is. It's a number. It's somewhere on the network. It's not meaningful. The SMB accounting file server, that is meaningful. That is the thing I want to talk to. But there's no mapping of that. And so if you have an IP, we by default say, we'll just do NTLM because we don't care. And then there's other scenarios like we have tried saying, hey, I'm trying to connect to the SMB file share, and the domain controller says, don't know who that is. So it's an aggregate, this 14%. And then of course, local users. I talked about that earlier. If I am on a workgroup machine, I'm not on a domain, I'm consumer network, or it's just a managed device somewhere in the cloud, doesn't have an account, it's not domain joint, it's not whatever. It's just going to do NTLM. That's just what it is. The local authentication system in Windows doesn't understand anything else. It's just NTLM. That makes up 29% of all NTLM authentication. I think that's 48%. And this is intentional. This is things that we could not do better. 48% of all NTLM traffic is something that we tried to do something better, fell back to NTLM because we couldn't for some reason. And we know we couldn't for some reason. We need to do something about that so that we can solve these problems so that when we do fall back to NTLM, it's actually for no reason at all. We aren't falling back, right? If I have a local user account, if I have a line of sight issue, if I have an authentication, a server name issue, all of those things just disappear. They don't happen anymore because we know how to do it with a better protocol. And one of the interesting problems is, well, we could come up with all sorts of solutions to these problems, but we're Windows. We have this problem where there are billions of machines out there that are doing NTLM on a daily basis, for better or for worse. And so this thing needs to be built in, needs to be part of Windows core, can't rely on anything else, has to be everywhere, all at once. We also need to make sure that it solves the crypto problem, which is it doesn't take 6 hours or 3 minutes or some obscenely small amount of time to crack a password. And it can't just rely on passwords. Like, passwords are a pain. Like, passwords are great in some ways. They serve certain purposes. They will be around forever, but maybe in smaller and smaller quantities for specific purposes, bootstrapping purposes, for instance, things like that. But we really want something that isn't solely dependable on passwords. Well, what are our options? Well, we have OAuth, we have web-based protocols, we have SAML, we have this thing called Kerberos, actually. It's a bit of a shock to some people. People look at this and say, oh, Kerberos, that's gross. I don't want Kerberos. We spent years trying to kill Kerberos. I didn't. I actually quite like Kerberos. I spent years building it into Azure AD, actually. We actually spent the last 3 years optimizing it in Windows, making it better, overhauling. We actually rebuilt the entire crypto stack from scratch. Well, why is it better? Why is it better than NTLM? Why is it we're not doing something over another protocol like OAuth? Well, for OAuth, as an example, OAuth requires an IDP, an identity provider, something else. It's also web-based, so that's HTTP. Web servers, that requires TLS, that requires certificates, and as soon as you start going down that rabbit hole, it's really complicated. We also don't want to take a dependency on things like the cloud. There are scenarios that can't. So it has to be central to the one thing. So Kerberos actually works. Kerberos is just a protocol. It's actually a deceptively simple protocol wrapped in a bunch of complex goo that nobody understands. And I will save you by not explaining how it works. First of all, crypto about Kerberos is a lot better than NTLM. At the very least, we're not relying on stupid things like MD4 and HMAC MD5. But we have RC4. Well, we actually don't anymore. Back in November of 2022, we killed RC4 incidentally. There was a security vulnerability that we found. Well, we didn't find. It was reported to us, and we had to fix it. Kind of scrambled to fix it. One of the interesting side effects of that MSRC was that we didn't just do it to kill RC4. We actually did it to make it crypto agile. And when I say crypto agile, what that actually means is at any given point in time, if we need to, we can pick up an old cipher and replace it with a new cipher. And that's important because if you have a break, such as with RC4, we can say, oh, okay, well, we'll just, overnight, we'll just replace it with a different protocol, or with a different algorithm. Well, that was one of the things we spent a very long time on. As a result of November 2022, since then, RC4 usage in Kerberos, as far as we can tell, has dropped to 0.03%. I'm getting in trouble for telling you that. Another fun fact, Kerberos, by its very nature, because it's based on symmetric crypto for its authentication, it's mostly quantum safe. To make it more quantum safe, the only thing we have to do is increase the key size. It doesn't have asymmetric problems. The other side of it is Kerberos inherently supports arbitrary credentials. That's how we do smart card auth. That's how we do FIDO auth. It's how we do Windows Hello, things like that. We could, as a result, bolt on all of these different things into Kerberos. Fun fact, when you're doing smart card authentication and you need to access an NTLM service, it actually relies on Kerberos to get you to that NTLM challenge, or challenge response. So Kerberos is everywhere. But I said Kerberos, the better protocol, cannot be used because we're falling back to NTLM. Well, how do we deal with that? First problem, line of sight. In order to do Kerberos, I have to go talk to a domain controller first. I do an AS. I get an AS rep. I've done my authentication. I have a password. Please give me a TGT. And then I use that TGT. Please give me a ticket to the thing I'm trying to talk to. And I've done all of that before I've actually talked to the thing I care about. Well, if I don't have line of sight to that domain controller, I can't do Kerberos. Full on. Just can't do it. So we want to flip it. So the thing that I care about, that file server, that mailbox, that whatever, is doing the Kerberos for us. And the important thing is we're doing that in such a way that we're not revealing the password to that thing as well. That's actually an interesting side effect. We need to do Kerberos end to end. There is no way to do that today with plain old Kerberos. It just doesn't allow it. Until now, where we have this protocol called IAKerb. It's an IETF spec'd protocol. Believe it or not, it actually started in like 2003, and it's just been iterated and iterated and iterated, and it stands for, and I quote, the initial and pass-through authentication using Kerberos v5 and the GSS API. Does anyone understand what the hell that means? A couple people. For those that don't understand what that means, what? What it means is someone from Microsoft named it. As a protocol, it's actually really simple. Like I said, with Kerberos, we have me. I need to go talk to a domain controller. I have a password. I have a password. Please give me a TGT. OK, I have a TGT. Please give me a ticket to this thing. Now I have this ticket to this thing. I want to go over here and access this thing. All of those things, all of those communications happen between me and the domain controller before I talk to this other thing. Well, what happens if we move the domain controller to the other side of the equation and we make the thing we're talking to pass all of those Kerberos messages on our behalf? I have done an AS rec. I got an AS rep. I'm doing a TGS rec. I'm getting a TGS rep. All of those communications just flow through the application I'm talking to. That's what IAKerb is. It's very simplistic in nature. All it's doing is it's taking the message that I normally would have sent, and it's doing it on my behalf. OK, well, that's cool. Congratulations, you've solved 5% of NTLM issues. And today, it only works in domain environments, because you have to have a domain controller. Well, that's actually not quite true. You don't need a domain controller. You need something called a KDC, which is Kerberos Key Distribution Center. And like I said, Kerberos is just a protocol. There's nothing inherently special about it, aside from the rights that you grant it and the controls that you rely on it for. Well, okay, we have this local user problem. If I'm trying to communicate with another machine and that other machine doesn't rely on some third party to actually prove my identity, what do? In the local case, that thing that's proving who you are is within the local machine itself. Okay, well, what if we shoved this KDC thing onto your computer? It's called local KDC. One of the interesting things about this idea, it's not novel per se. There are other systems out there that do rely on this. We talked about, we looked at this years and years ago, and we thought, it's not important, until we realized that NTLM is terrible and we need something to replace it. So the basic idea with this, we still have this relationship where we have a machine that we care about, and on that machine is the user identity. In Windows, that exists in something called the SAM, Security Authentication Manager. Well, what if we plop KDC right on top of it? And when I do an ASREC, I go to that KDC. And that KDC says, oh, okay, well, I understand your password. I'm going to give you a TGT. And here's your TGT. Please give me a ticket to the same machine. And one of the cool behaviors about this is historically Kerberos relies on specific TCP port, specific IP ports, TCP 88, UDP 88. We don't want to open another port. One of the other problems is, how do you find that port? How do you know what thing you're talking to? So as a result, we've foregone all of that and said, well, we already solved that from the transport perspective by using IAKerb. Okay, we'll just do IAKerb to this machine. And it turns out that instead of the machine forwarding on some domain controller, it just says, oh, I have that user. I can do this all locally. And it does. It's plain old Kerberos. Cool. We're done, right? Yeah. Well, let's see. 29% plus, what did I say, 5%? Okay, yeah, that's 100%, right? Not quite. See, I told you I had a joke about it. No, 48%, right? There's some 14% missing. What did I say was 14%? This unknown server problem. What do we do when Kerberos can't find a server that it wants to talk to? One of the things about Kerberos is it has server authentication built into the protocol. The way that it works, and like I said, I'm not going to explain how Kerberos works, but the way that server authentication works is there's a key exchange that happens between my client and the server when I've talked to it, when I've authenticated to it. And that server responds back with another thing that shows proof that it decrypted the ticket that it received. By virtue of the fact that it decrypted that ticket and it proved to us, we know that it is the server we actually asked for. NTLM can't do that. And we have this problem where with a regular domain controller, we've tried to ask it, I'm connecting to this file server, and the domain controller can't find anything. So what do we do about that? That turns out to actually be an incredibly difficult problem. And the answer to that is we're doing nothing about it because it's a security issue. This is a security flaw. This is a problem. This is, I have connected to a website, and the website, and the browser says that this website is not what matches the certificate. This is bad. Well, that's what's happening here. We're saying, no, we're not doing it. Well, that's actually 48%. So are we done? No, because we're still only at 48%. 48% is not 100%. What about this other 52%? Developers, man. The problem with hard coding NTLM is that there is nothing we can do about it. Ideally, you have said, I want Windows to negotiate and do something else. And that's how we've solved those other 48% of the problems. What do we do about hard coding it? Nothing. We can't do anything about it. Like, we can't go into Windows and say, you're doing NTLM. No, you're actually doing something else. We can't do that. That's a contract that we cannot break. So how do you fix it? Well, First things first, who is hard-coding it? There is one app or one service built into Windows that makes up 30% of all NTLM usage. Not 30% of the 52% hard-coded, 30% overall, 30% of 100.
Remote desktop.
No, it's not remote desktop. Anyone? So if you know the answer to this, because you've seen me give this presentation before, you've talked to me about this, don't answer, but who can guess what it is? Sorry? SMB. Not SMB. ADCS. Good answer, but that's not 30%. It's actually less. But it's a good answer, because it does. It is actually hard-coded. Anyone else?
Clustering.
Clustering. Clustering doesn't hard-code it, but it does do NTLM as a result. Well, first of all, there is one thing, literal order of magnitude, is that 30% does so many NTLM authentications because it hard-coded it. And that thing is the spooler service. Of course it is. Never fails. I'm giving the spooler service a hard time. It's not their fault. Well, it's mostly not their fault. What happened? Well, spooler service uses RPC. RPC has this thing called the RPC binding set auth info function, whatever. Takes a parameter and it says that parameter is the thing that you want to authenticate with. And they say, oh, just use the default. Actually, that's quite reasonable in my mind. Well, the default in Windows, NTLM. So how do we fix that? Oops. Well, you just change it. It's spooler service. Change it to negotiate. Easy enough. That's literally all we have to do. If you have a hard-coded app that's doing NTLM because it's hard-coded to NTLM, we're actually just asking people, hey, stop doing that. Move it to negotiate. If you are relying on NTLM for a very specific reason, negotiate understands that. It knows that's why the other things fell back. Just move to negotiate. Negotiate will figure it out for you. It may still do NTLM, but that's fine. We can work with that. And there's this other thing. I'm not going to tell you who it is because it's a third party. I'm not going to say that they're actually doing it on purpose. We don't know why they're doing it. They just show up in the data. They're like 10% of all NTLM. Don't know why. We have to go talk to them. How do we deal with that, right? Well, it's not just them. There are actually a lot of people who hard code NTLM, as we know, by virtue of the fact 52% of all NTLM authentications are for that reason. Well, we have to go ask them to do it. And so we have this hard problem where we literally have to go find someone to talk to and go say, hey, can you please do something about this? Pretty please, in your supported versions, and go ask all of your customers to upgrade from something other than Server 2003, please. And if that doesn't work, we'll go the SMB one route, and we'll basically say, these are the things we know require NTLM, that they're hard-coded. We'll let the customers decide, oh, is this thing on the list? Oh, we should go talk to them. Say, hey, can you do it? We're giving you money. Can you please fix this? And then, of course, clicky thing's not working. Maybe we break their apps. No, we're Microsoft. We don't do that. That's a terrible idea, unless we do it on accident, in which case, our bad. We don't want to do that. That's actually, our goal is not to break things. We just aren't very good at meeting that goal. So, lastly, there's all of these other things. IIS, website-based stuff, and Outlook talking to Exchange or SMTP or whatever. Those make up 6%, give or take. And then lastly, there's like everything else, which fits into this 10% bucket. Honestly, we're focusing on the first 86, 84%. We have enough on our plate to deal with that hopefully those third parties, hopefully those internal outreach things will solve some of these problems, and eventually it'll just kind of slowly disappear. And over time, we'll get there. And if we can't, well, we'll figure something out. Who knows? Please, if you're a lawyer in this room, don't come talk to me. I don't know what we're going to do, honestly. Like, if we get to 80% of all NTLM authentication going away, I'm done. I'm going on vacation, right? Like 80% of all NTLM traffic authentication gone. That's amazing. Like that's an amazing breakthrough. So we'll see what we can do about it. Which brings us to our final thing of, well, when? When are we doing this? Well, today. This is a project. I've been working on this for 2 years now. Between the Kerberos stuff and the RC4 stuff and all of these things. I've been working on this for a long time. Our team as a whole have been working on this for a long time. It's not just me, it's a whole team-wide effort across all of Microsoft. And so our goal is to get it out over the next couple of years. You know, we have to do this in baby steps. We can't do it immediately overnight, suddenly turn it off, we break the world. It doesn't work that way. So we're gonna do it over time. Next couple releases of Windows Server, all that fun stuff. It'll be available over time. And then eventually, we'll get to turning it off by default. And that's it. That's my talk. Thank you.
Thank you, Steve. Appreciate it. Great job.
Thank you.